Dear students, in this lecture, we are going to discuss about pure capacitor excited by AC supply. So, as we know that capacitor is consists of two insulating plates which are separated by some insulating medium or a dielectric medium. It is acted as a capacitor. Capacitor is nothing but it consists of two insulating plates or two plates which are separated by dielectric medium or air. It stores the energy in the form of electrostatic field. Capacitor stores the energy in the form of electrostatic field. The capacitor works as a storage device. So capacitor also works as a storage device like inductor. Inductor stores the energy in the form of magnetic field, whereas capacitor stores the energy in the form of electrostatic field. It gets charged when supply is on and it gets discharged when supply is off. So here we can observe the pure capacitor which is excited by AC supply. Let us consider a sinusoidal AC signal is applied across the pure capacitor is taken as V equals to Vm sin omega t, that can be also written as Vm at an angle 0 degrees. Sin omega t can be also written as 0 degrees reference signal. So the voltage signal is always starting from 0 degrees, which is acted as a reference signal. So initially we are applying the instantaneous AC voltage across the pure capacitor, that is taken as Vm sin omega t. Let the alternating voltage is taken as Vm sin omega t, and the charge is stored in the capacitor, as we know that the charge stored in the capacitor at an instant of time is taken as Q equals to Cv, as we know that the charge stored in the capacitor equals to Q equals to Cv. So the current flowing through the circuit is given by, as we know that I equals to dq by dt. I equals to dq by dt. Putting the value of Q in above equation. So I equals to d by dt of Q is nothing but Cv, where C is the constant term or capacitance of the capacitor. So C into V. So now putting the value of V, instantaneous value of supply voltage. So I equals to d by dt of C into V is nothing but we are taking Vm sin omega t, reference signal Vm sin omega t. So C into constant term, C into constant term Vm into d by dt of sin omega t. So here it look like d by dt of sin at formula. Here it look like d by dt of sin at formula. So C into constant terms, C into Vm into d by dt of sin at formula is A into cos at. A into cos at. So A is nothing but omega. Omega into C into Vm into cos omega t. So here Vm into omega C can be written as 1 by omega C. Vm divided by 1 by omega C. Omega C can be written as Vm divided by 1 by omega C into cos theta can be written as sin of theta plus 90. Cos theta can be written as sin of theta plus 90. So sin of omega t plus pi by 2. So Vm by 1 by omega c is taken as xc. 1 by omega c is taken as xc. Xc is nothing but capacitive reactance. Capacitive reactance is nothing but resistance of the capacitor which opposes the flow of AC current is nothing but capacitive reactance Vm divided by Xc, whereas inductor XL which opposes the flow of AC current, XL is nothing but inductive reactance is nothing but resistance of the capacitor. Here Xc is the resistance of the capacitor is nothing but capacitive reactance. So Vm divided by Xc into sin of theta plus 90 pi by 2. So where Xc is taken as 1 by omega c, it opposition offered to the flow of alternating current by pure capacitor. It is also known as capacitive reactance XC, capacitive reactance XC. So the value of current will be maximum at sin of omega t plus pi by 2. Omega t plus sin of theta plus pi by 2 is nothing but 1. So therefore the maximum value of current Im will be given as Im equals to Vm by Xc. So Vm by Xc is taken as Im. So substitute the value of Im in previous equation. I equals to Vm by Xc is taken as Im. Im into sin of omega t plus pi by 2. That means it is also written as Im at an angle plus 90 degrees. I am at an angle 90 degrees here plus pi by 2. Whereas inductor I am sine of omega t minus pi by 2. I am minus 90 degrees. I am of minus 90 degrees for inductor. Whereas capacitor I am sine omega t written as I am at an angle 0 degrees. I am 0 degrees plus 90. I am of 90 degrees. So that we can see the voltage signal, current signal as well as power signal. So as we know that the phase angle between the pure capacitor, the phase angle between the voltage and the current is 90 degrees. So that current leads the voltage by 90 degrees. Here plus 90 is obtained. The derived current signal is obtained by plus 90 degrees. So that current leads the voltage by 90 degrees. So always we are taking voltage signal is a reference signal which is starting from 0 degrees and terminating at 2 pi radians. And current signal is starting at plus 90. Plus 90 will be here only. This is 0 or 360, here 180, here 270 or minus 90. This is 0 or 360. So current signal is starting from 90 degrees plus 90 degrees. So the current signal will be look like this. So with the help of this voltage signal and current signal, we can draw the power signal from 0 to pi by 2. From 0 to pi by 2, the current signal is in positive direction. The voltage signal is also in positive direction. So that plus into plus, the power signal will be plus. Similarly, from pi by 2 to pi, from pi by 2 to 90 to 180 degrees, from 90 to 180 degrees, the current signal is negative, the voltage signal is still it is in positive. So plus into negative, negative, so that the power signal will be negative. From pi to 3 pi by 2, from pi to 3 pi by 2, that means 180 to from 180 to 270 degrees. The current signal is in negative, the voltage signal is also in negative. Negative into negative, positive. So the power signal will be positive. From 3 pi by 2 to 3 pi by 2 to 2 pi, that means 270 degrees to 360 degrees. So the voltage signal is in still it is in negative. The current signal is also in it is also in where is current signal positive. So plus into negative, negative. So still the power signal negative, negative, plus into minus negative. Next, we can also calculate the instantaneous power for pure capacitor which is excited by AC supply. So instantaneous power is given by P equals to small letter P equals to V into I. V is nothing but reference signal Vm sin omega t. I equals to current flowing through the pure capacitor derived signal Im into sin of omega t plus 90. 90 is nothing but pi by 2. So Vm sin omega t into Im into sin of omega t plus pi by 2. So Vm into Im into sin omega t into sin of theta plus 90 is written as cos theta. So cos omega t. So here also we can multiply and divide it by the 2 in this equation. Vm 2 can be written as root 2 into root 2 Vm by root 2 into Im by root 2 into sin 2 theta. 2 sin theta cos theta. Here 2 sin theta cos theta is nothing but sin 2 theta. So Vm by root 2 into Im by root 2 into sin 2 theta. Again this equation contains sine function. So that per pure sinusoidal signal, sine function or cosine function pure for complete cycle, the average value will be 0. So that the average equation, the average power will be obtained by integrating the instantaneous power over a one cycle. So automatically the sine 2 theta 2 omega t value will be 0. So that as in pure capacitor also the power dissipated in pure capacitor also 0. So hence it is clear that the average power in pure capacitor is also 0. Whereas inductor also pure inductor, the dissipated power also 0. So in this way we can derive the power signal, current signal when pure capacitor is excited by AC signal with reference signal of V equals to Vm sin omega t. In next lecture we will see the what is impedance, admittance, pure series RC, series RL and series RLC circuits excited by AC supplies.